Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 29, 2025, about 2 days ago. This paper introduces a dense-to-sparse, switchable attention that runs about 4 times faster than dense attention, while retaining 98.1% of long context understanding and 99.7% of chain-of-thought reasoning performance. The paper is titled InfLLM-V2, Dense-Sparse Switchable Attention for Seamless Short-to-Long Adaptation. And, as we will see later, the implications for model training are quite significant. Beyond speed, it reuses the original dense parameters with no extras, transitions smoothly across input lengths, and adds an efficient kernel that trims block selection to approximately 1.25 times cost. Alright, the introduction set the stakes for long sequences. Figure 1 shows a side-by-side comparison of NSA, vanilla full attention, and InfLLM-V2. The NSA column stacks 3 key value projections, 3 attention modules, and a gated output, which makes it redundant, expensive, and unstable. The vanilla column keeps a single key value, a single attention, and a single output. The InfLLM-V2 column shares the dense key value, unifies attention, and keeps a single output, so it stays reusable, portable, and aligned with pretrain-on-short, then finetune-on-long. So Figure 1 showed the architectural contrast. Figure 2 presents the pipeline side by side, which clarifies why the new design stays lightweight. The top panel depicts NSA with 3 separate key value projections, 3 attention modules, and a learned gate that mixes their outputs, so extra parameters pile up. The bottom panel shows a single shared key value feeding dense attention for short inputs and a fused sparse attention for long inputs. The center switch by sequence length selects between these 2 paths without retraining. Alright, Figure 2 contrasted the pipelines in past tense. Table 1 reports results on the ruler benchmark at 32,000 tokens, which compared dense baselines with several sparse schemes. The sparse InfLLM-V2 averages about 83%, closely tracking full attention at 84%, while training free methods fall far lower. The LSE approximation variant matches the sparse scores, so the acceleration costs no quality. The dense mode of the same model even reaches about 88%, slightly surpassing the dense baseline. So, Table 2 broadens the comparison from ruler to real long context tests. Table 2 shows that the sparse InfLLM-V2 reaches about 42.5 on long bench, with perplexity near 2.12, which essentially matches its dense mode at about 42.5 and 2.00. Short plus yarn and NSA land far lower, around 38 and 37 on long bench with higher perplexities. Minference trails with roughly 41.6 and 2.62, so the gap remains meaningful. So, the previous table compared accuracy and perplexity. Figure 7 shows end-to-end speed for the 8 billion model with 6,000 visible tokens, split by pre-filling and decoding on A100 and on 4090. Sparse attention cuts time as sequence length grows, because attention work shrinks while other time stays similar. The largest gains reach about 2.1 3 times faster pre-filling and 2.3 2 times faster decoding on 4090 at 128,000 tokens. Wrapping up, 2 takeaways stand out. Dense to sparse switchable attention reuses the original dense parameters, so short to long adaptation stays stable with almost no accuracy drop, and the fused sparse kernels deliver 2 to 4 times speedups in practice. The broader implication is cheaper long context models that fit standard training workflows. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.